Okay, so I'm going to do several problems here and there, and I'm gonna try to get the breadth of everything. On this particular problem, you're supposed to do the limit graphically. And if you look at this, what this question's really asking you is, you've got this nasty function. What happens when x gets close to 1? And if you put your x close to 1 and just drop down the graph, it looks like -3 is your answer. That's what's intended. But I'm going to give you a series of steps here that will always work if you don't have a graph. So let's just do this one outright. So how to find a limit step by step for x going to some number. C's got to be a number. C is not plus or minus infinity. It won't work there. Okay, so step 1, you should always plug in 2 numbers that are close to 1, just so you get your answer. We got it off the graph anyways, but pretend we didn't see the graph. So we're doing this limit as x approaches 1 of x cubed minus x squared minus 4x plus 4 over x minus 1. So step 1, plug in x equals 1.001 and 1 below it, just to be sure, because things do go crazy. Let's put 0.99. So I'm going to do that, and I'm lazy, so I'm going to just do it on a computer. You have a calculator, and you're pretty good at doing these things. I'm just going to put the y value over here, and I am going to use Excel because I'm lazy. So I'm going to put in 1.001, here my x, and 0.99, and then my y value was, you can see me typing it, x cubed, which instead of x, I'm going to have a2 cubed minus a2 squared minus 4 times a2 plus 4 divided by a2 minus 1. And you won't get a 0 in the denominator because it's not 1 minus 1. So what do I get? I have to put it equals here. I get minus 2.99. In the computer science world, that's -3. And then let me just double check. Yeah, it looks like the answer is -3. So I get here, I get the answer. Minus 2.998 minus 3.0199 looks like -3, which we already saw from the graph, so we know that's right. How do you do this, though, analytically, without the graph and without numerics? You have to factor. If you actually have a numerical answer here, you have to factor. Step 2, if the answer in step 1 is a number, same number on both sides of 1, factor. We have to factor. So here you're going to factor by grouping. This is a setup. So if you look at the top, I can see x cubed minus x squared. I can factor an x out of that, and I can factor a 4 out of the second part. This is why you learn factoring when you're little. So I get, if I take an x squared out, I get x minus 1 in that first part. And if I take a minus 4 out, I get an x minus 1 here. Just double check. X squared times x gives me x cubed. X squared minus 1 gives me minus x squared. Minus 4 times x gives me minus 4. Minus 4 times minus 1 is plus 4. That's divided by x minus 1. Now, I take that, this guy here, and I'm going to take it further. We go to the next page, plug it in up here. If I take this guy and put if you notice, there's this thing here and this blob here. I can factor it out. This is equal to x minus 1 on the outside, and then x squared minus 4 on the inside. Left over, distributive law. X minus 1 times x squared gives me the first term. X minus 1 times negative 4 gives me the second term. That's divided by x minus 1. I'm just going to put parentheses there so you can see they really are the same. And then we can cancel that. I told my students this was cancel culture. It feels fun. And I get x squared minus 4. So now there's no denominator anymore. So I can plug in 1 exactly. Step 3, plug in x equals 1, thing you're approaching. And I get 1 squared minus 4 is equal to 1 minus 4, which is, lo and behold, the answer I got earlier. So the answer you get with your numbers gave you the same answer that you get with analytics. What's nice is you're less likely to make a mistake with the numbers and get the answers, like you have the answer for free. All right, I'm going to go to another problem.